Frequency calculation is one of the fundamental tasks in computational chemistry. It is a common practice to first optimize geometry and then calculate its frequency to check whether it is a true minimum or transition state and obtain zero-point vibration energy and other thermochemical corrections. Here we demonstrate how to use MLatom for frequency calculation. First, we do this on Zach's cloud. Enter the task name. Then upload the input file or enter it directly here. Next, upload the auxiliary file, which in this task is the optimized geometry. Then submit the task. You can view the progress and results of tasks in the Job Manager. Now we show how to do this in Python. First, import MLatom as a module. Then get the initial guess for the molecules to optimize. And choose one of the predefined methods. Then optimize the geometry with the chosen optimizer. Now we get the optimized molecule. Next, do vibration analysis and thermochemistry calculation. Save the molecule with vibration analysis and thermochemistry results. Last, check vibration analysis and thermochemistry results. After completing the script, we upload the initial geometry file. Run this script. And then we can see the results. If you have further questions, criticism, and suggestions, we would be happy to receive them in English or Chinese via email, Slack, or WeChat. Please send an email to request to add you to the Zach's user support group.